Okay, how can we implement a backdoor? And in 10G, after the DLL is generated on the operating system level, this file is imported into the database and stored into a C log in 10G. But even then, here you can modify stuff. This is a part of the C file. Okay. Now we can implement such a backdoor like this trigger if we send a special parameter to the system that we destroy the database or generate a shell. And now we did a modification in the data dictionary. So we have traces in the data dictionary. But first, Oracle generates a C file. This C file is compiled. And then from this compiled file, we are generating a backup. Then we have a backup of this DLL. And the next step is we remove our Trojan from the PLSQL procedure. And then Oracle again generates the C file and generates a DLL. And now this my procedure in the database does not contain any modification. So the checksum is not modified. And now we have the DLL without the modification, and we have a copy of the backdoored system. And now we replace the unmodified DLL, and every time someone calls the unmodified PLSQL procedure, Oracle is executing the backdoored DLL on the operating system. This happens because Oracle does not monitor the system, the DLLs on the operating system level. So it's up to the DBA or developer to delete these files. And in this case, we don't have a modification in the system, but Oracle is executing something different. The good thing is most people don't use PLSQL native. For some special cases, you can have a big performance improvement, but I would recommend not to use PLSQL native. And you should also check your database for objects compiled in this PLSQL native mode, because it's not necessary to compile everything in this mode. You can only have some special packages compiled in this mode. And if you need this, you should also check these DLLs and libraries with checksums. So the first possibility, patching binaries. The second, PLSQL native. Now the third possibility, it's quite an old technique called pinning. Pinning is available since Oracle 7, because Oracle in earlier versions had bigger problems with memory fragmentation. So every time you execute a PLSQL package, this package was loaded in the memory. And if there was not enough memory available for this package, if the package was large, you got an error message called error 4031, Bambamina error something. And to avoid this, it was possible to preload a package into the memory. And for this reason, Oracle has a package called DBMS Shared Pool, and DBMS Shared Pool allows you to pin or to preload packages into the memory. The problem with pinned packages is if you change the object, the package is not automatically reloaded. So still the pinned package is executed and the code from this pinned package. Here's an example. We have again our my procedure and the SGA. And now we implement a backdoor in the my procedure. And now with the command dbms shared pool.keep my procedure, we are preloading this my procedure package into the memory or procedure. And now every time you execute my procedure, Oracle executes the code from the memory and not from the database. And now we undo the change in the database. So again, we have no sign of modification, and as long as the database is not stopped, we are always executing the backdoored package. And that's why if you are using databases, you should check if the package dbms shared pool is installed and what packages are pinned. And if you believe you are the victim of a database attack, before stopping your database, you should generate a memory copy of your database. Because if you shut down the database, all the traces are gone. So you have no incident, no evidence anymore. So in this case, you should check if dbms shared pool is installed, and you should check on a regular basis for pinned packages. Here are some other possibilities. For time reasons, I was not able to implement it, but I'm quite sure that you can also implement rootkits using these techniques. One is virtual private database. With virtual private database, you can modify the SQL statements afterwards. So even if you run a select star from a table, you see only parts of the table. If virtual private database rule modifies the SQL statement. One possible victim, for example, could be HTMLDB or Apex. It's an application from Oracle, which is part of Oracle Application Express Edition, this way. And in Oracle HTMLDB, all the user credentials are stored in a table flows 020100 www flow fnd user. And if you create a virtual private database rule on this table, you can exclude special users depending on the time or something like this. And the only way to get rid of virtual private database and to see the real content of the table is you must work as sys, or you need a privilege exempt access policy. But if you do this, you disable the entire virtual private database concept. So at least if you do a security audit, you should always work as sys or with this exempt access policy. Only then you can guarantee that you see really everything, the real information, not modified or tampered information. Another possibility, Oracle is full of these features and functionalities, is called query rewrite. With query rewrite, Oracle is able to modify statements. For example, the user submits a select star from table A, and Oracle tries to optimize this statement, and if there are, for example, materialized U, Oracle completely rewrites the statement, replace object names and so on. And Oracle is replacing the select star from table A with select star from table B. And if you have a modification in table B, you can show something different. So this is also one possibility. But this is also not enabled by default. It depends always on your configuration, what you are using. Third generation rootkit. It's much more difficult to implement. Since Oracle 10G Release 2, there's an official API, and this API allows you to modify the SGA. So you can directly modify all information in the memory of the database. You can modify blocks, you can modify statements, and so on. To do this, you must run an operating system program, and with this program you attach to the database SGA, and in this system you can modify objects. And Oracle is doing this for support reasons. So if you have a problem with your database and you are not able to run select statements, then you can directly attach to the memory and try to resolve the problem in the database. One of the problems of database rootkits is the question, how can you survive updates? Because nowadays, every 3 months, you have critical patch updates from Oracle, and even if you don't apply every critical patch update from time to time, you apply, or you should apply, critical patch updates. And during this update, a lot of the objects are recreated from scratch. So, for example, you recreate views, you recreate packages, you override packages. And then the question is, how can we survive this? One of the possibilities is we can create a special database job, and this database job checks every day or every hour for a modification of the database objects. The second possibility, we can modify the glogin.sql on the database server. This file is automatically executed if someone connects with SQL Plus from the server to the database, and then this code is executed automatically in the background. Then we could also create or modify a database startup trigger, so whenever the database is restarted, we can check if our modification is still working. We can pin packages, stuff like that. Or we can backdoor custom PLSQL applications, because in most companies the PLSQL code is not only coming from Oracle, it's also coming from customer applications. So if we implement this backdoor in a customer code, this is normally not modified during an Oracle patch update. And normally it's always a battle between good guys and bad guys. If you say, okay, in this case we are doing that, there's always a possibility to survive such a modification. Finding rootkits, checksums. You should have checksums on database objects, because as long as the packages from Oracle are wrapped, you have no possibility to see what's inside such a package if you don't have these tools. Then you should also check some binary files, but it depends always a little bit on your level of paranoia. If you have hundreds of databases, not every database must protect it this way. But it's up to you to decide, okay, this is a critical database, and we try to avoid modification. Sometimes you can also compare the checksums afterwards if you believe there was an incident, or if you have a change in the DBA group, you can check and compare the checksums. And normally two identical patched database systems should have the same checksums of the PLSQL packages and executables. Then you should check if PLSQL native is active, and if someone is using it. You should also check for DBMS shared pool, and the best protection is always harden your database and apply the latest security patches. And change your default passwords. So from my experience in security audits, in many companies there's no need to install a database rootkit, because in most cases you can log on with DBSNMP. But in the future we will see that more and more databases are becoming stronger,